Okay, let's go ahead and get started. Or not, let me answer an email real quick. All right. So, did everybody get the review that I sent out Friday? Did anybody not get it? Everybody got it? Good. Okay. I don't know how many of us have looked at it yet. I know if I was one of y'all, I probably wouldn't have either. But remember that it is due on Wednesday. Okay? So what I'd like to do today is I'd like to take some time and go over a different version of the review that I have here and maybe get some problems we're having out of the way. Hello, Alyssa. So, this is the exact same order of questions that we have on the review. It's just different numbers from what we have on the actual one. Number one, determine the following radical expression, or if the following radical expression is a real number. If it is, you are to evaluate the expression. So there's two parts of this. One, we have to determine if it is a real number. And the second part is we have to evaluate it if it is a real number. Okay, well, the only thing that would be keeping this from being a real number is having a negative underneath the radical. Now, there is a negative present here, but it's outside of the radical, so that doesn't really make a difference. Okay? So, this is a real number, so we're going to have to write that down. And now evaluate it. And what we mean by evaluate is simplify this thing. So first of all, can we take the square root of 169? So, oops. If we plug that into a calculator, yeah, indeed, it's 13. So this is really 13. Drop that negative down, we have negative 13. So there's the second part of our answer. Any questions? None? Okay. Next one, simplify the following radical expression. So no question about is it a real number or not, just simplify this thing. So we've got a square root, and underneath it we have 64 and y to the second. So let's look at the number first, 64. What is the square root of 64? 8. So there's one part. Then we have y squared. What's the square root of y squared? Y, yeah. Remember that what we're doing here is we're saying since this is a square root, so 2 in the crook there, we're dividing this number, this power, by the type of root. So 2 divided by 2 gives us 1, or just y to the power 1, or y. So our answer there is 8y. Any questions? All right, next one. We have another root, and this is probably pretty hard to see, especially for the people on the stream, but this is the square root of x to the 4th over 144 x to the 6th y to the 14th. Now remember, one of the properties of radicals says that we can think of this as being separate on top and bottom. So we can separate this as square root of x to the 4th and square root of all this stuff down here. And it's the exact same thing we just did up here. So square root of x to the 4th, what is that? Remember, we're taking this power and dividing it by the type of root, which is 2. So it's 4 divided by 2. It's 2, so we have x to the 2nd. Okay? On the bottom, we have 144. So what is the square root of 144? Nobody? 12, yes. So we have 12. Then we have x to the 6th down here. So again, we're going to take that power and divide it by the type of root. So we have x to the what now? X to the 3rd, yeah. 6 divided by 2 is 3. And then same thing for the y. We have y to the 14th. So 14 divided by 2, we have y to the what? Good. Now, there's one more thing we need to do here. We have x to the 2nd on top and x to the 3rd on bottom, which means we can divide these. Okay? So first of all, which one has the bigger power? The top or the bottom one? Bottom one, yeah. So that means when we subtract this, the x is going to end up on bottom. We won't have an x on top anymore. So all will be left up there is 1. All right? When we divide powers, or divide things with powers, what do we do with those exponents? Add, subtract, multiply, or divide them? Subtract. So 3 and 2, what's the difference of 3 and 2? 1. So x to the 1st on bottom here. And that is as far as we can go. There's no more simplifying that we can do. Any questions? All right. Next one. Simplify the following radical expression, and it gives us square root of 20. Now, if we were to plug this one through our calculators, square root of 20, that gives us a decimal. I do not want this decimal. Okay, what I want you to do is, like it says, simplify. And of course, what we mean by that is to take this and factor it up. So split it up into numbers that will multiply to get 20. And we're going to use those numbers to simplify the overall radical. So what are two numbers that will multiply to get 20? 5 and 4. What can 4 be split up into? 2 and 2. Now remember that the goal when we're splitting these things up on radicals is to find numbers that match in the amount of the radical. So this is, again, a 2 in this crook. So we want a pair of things. If this were a 3 in the crook, then we'd want a group of 3 things that match. But we just need 2 things that match, so do we have 2 things that match? 2 numbers that match? Yeah, 2's. So that's the thing that we can take out. So this is taken care of. Now what's left over? 5. And that is still underneath the radical. Any questions? All right. 5. Again, simplify the following radical expression by rationalizing the denominator. So that's a big one. We need to rationalize the denominator. Well, first, this is a fraction. We have the square root of 14 over the square root of 21. Do 14 and 21 have something we can divide both of them by? 7. They can both be divided by 7, which means we can simplify this overall fraction. So if we divide both of these by 7, we get square root of 2 over square root of 3. Okay? Now we've simplified, but we need to rationalize the denominator. And rationalize means, well, square root of 3 is irrational. If we plug that into a calculator, we get one of those big, long decimal things. We don't want that. We want the bottom part of this fraction to be rational. So we got to get rid of this square root. So how do we get rid of the square root? Square it, yeah. So squaring, of course, means multiply it by itself. So we'll multiply square root of 3 times square root of 3. That will get rid of that square root symbol. We just have 3 on the bottom now. But what else do we need to do here? Same thing on top, yes. So if we multiply the bottom by square root of 3, we have to multiply the top by square root of 3 as well. So square root of 2 times square root of 3, we get square root of what? Square root of 6, perfect. And there's our answer, square root of 6 over 3. Any questions? Okay. Next, convert the given expression to radical notation. So what it gives us is z to the 5/4 power. This is right now in exponential notation. So we want this to be radical notation, which means as a root. So remember that in this exponent, one of these numbers is the type of root, and one of these numbers is the power that is going to be on z. So which one is the type of root? Again, we have 5 over 4. Four, yes, good. The bottom number, the denominator of that fraction in our power, is going to tell us what type of root we have, or the denomination. Then underneath this root, we will have z to the 5th power. Remember that what we're doing, just like up here, we take the power divided by the root. So 2 divided by 2 is 1. Take the power divided by the root. So 14 divided by 2 is 7. Same thing here. Take the power divided by the root. Well, 5 and 4 don't really divide evenly, so it's 5/4 power. Literally take that thing, divide it by the type of root, that gives you the power, and vice versa. Any questions? Okay. should have thought about printing these front and back. A little bit of an oversight on my part, sorry about that. In fact, we're going to need some extra space, why not? I'll just copy this one down onto another sheet of paper. So this one says simplify the following expression. Assume all variables are positive. Express your answer using rational exponents. And it gives us 5 x to the 1/2 y to the 1/2 over x to the 3rd times 7 y to the 1/3. Okay, so there's a few things going on here. First of all, we've got these numbers multiplying. We have 5 times x times y. Same thing down here, but it's written in a way so that the leading coefficient is not in front. We really ought to rewrite that so that everything lines up. So this would be 5 x to the 1/2 y to the 1/2 divided by 7 x to the 3rd y to the 1/3. Okay. So, remember, we have exponents on these numbers and we're dividing. So what are we going to do with these exponents? Add, subtract, multiply, or divide? Subtract. So what we really have here is 1/2 minus 3 for the x. Now, in order to subtract this, what do I need to do with 3? Yeah, good. Put it over 1, make it into a fraction. So 1/2 now minus 3 over 1. What else am I going to need to do here in order to be able to subtract? We need to get a common denominator between these two. Perfect. So, common denominator between 2 and 1, well, it's easy to make this into a 2. I just multiply it by 2. Okay, so now I have 1/2 minus 6/2, and that's going to give me negative 5 over 2. So that's the x part. Now, because it's negative, what does that mean about my x? It's going to be where? Top or bottom? Bottom, yes. If you subtract these things and you get a negative exponent, it's on the bottom. So now we have 5, no x here, we still need to figure out y, over 7 x to the 5/2. And it's positive now because we've switched it to the bottom. All right, let's tackle y. We have 1/2 minus 1/3. Okay, so once again, what do we need to be able to subtract these? Common denominators. So we have 2 and 3. What can we multiply both of them up to be? 6. So we'll multiply 2 by 3 and 3 by 2. That's going to give us 3 over 6 minus 2 over 6. And if we subtract those, that gives us positive 1/6. So we have 1/6 on y. Where's it going to be? Top or bottom? Top, because this is positive. So we have y to the 1/6 on top. And 5/7, we're going to have to basically keep it that way because we can't reduce that any farther. 5 and 7 don't have anything in common and they don't divide evenly. So this would be our answer. Any questions? Nothing? Okay. Back over here real quick. Number 8. Classify the following expression as either a polynomial or non-polynomial. So remember, polynomials have more than one term. Okay? And terms mean they have different things, like x or y, or even x squared versus x. Things that cannot be added. They're not like terms. So the thing to look for in a polynomial is, do we have addition and subtraction? So do we have addition or subtraction here? Yeah, it's right there. We have add and we have subtract. Easily, this is a polynomial. Now, looking back at the previous one, would we classify this as a polynomial or non-polynomial? Do we see addition and subtraction? Do we see addition or subtraction? No, neither. So this is a non-polynomial. This is monomial. This is a polynomial because we have more than one type of term here. Okay. Again, I'm going to switch to a different sheet of paper for this next one. So this one says, consider the following polynomial, and gives us 9 plus y to the 5th minus 5y to the 4th. The first thing it wants us to do is to express the polynomial in descending order. Of course, that means descending order of power. So our greatest power here is y to the 5th. So that's going to come first. The next smallest is 5y to the 4th. And then the next one would be 9, which is technically y to the 0 power. And so there's the first part of that one, to express it in descending order. Again, that means greatest power to least greatest power. Next, we want to know the degree. So what is the degree of this polynomial? Okay, remember, degree is the greatest power on a polynomial. So what is our greatest power? 5. So our degree is 5. Then we also want to know the leading coefficient. Good. Any questions? All right. Next, we have multiply the following polynomials as indicated. So this is 2y minus 6x times y plus 6x. Okay? So like it says, we need to multiply these polynomials. And anytime we see parentheses like this, something directly on the outside of parentheses, remember, distribute. So we want to use our distributive property to put this one into this one. So the first thing we can distribute is 2y. So let's see, what is 2y times y? 2y squared. Remember, it's 2 times what is really 1 right there, and y times y, which is y squared. Good. All right. Next is 2y times 6x. So what do we get? 12yx, or xy. Let's put it in alphabetical, since that's typically what we do. But good. Okay? So we've distributed the 2y. Nothing else to do with the 2y. Now we need to distribute negative 6x. Okay. So what is negative 6x times y? Perfect. And then negative 6x times positive 6x. Negative 36xy. I'm sorry, negative 36x squared, because it's x times x. Okay. So we've multiplied, but does that mean that we're done here? What else do we need to do? Combine like terms, perfect. So we have 12xy and negative 6xy, so together they give us what? 6xy. And then drop the rest of our terms down. Excellent. What questions do we have? Okay. Next. Find the product of the binomial factors using the appropriate special product, difference of two squares, square of a binomial sum, or square of a binomial difference. None of that matters. Remember, this is squared, so this means it is literally being multiplied by itself. So x plus 9 times x plus 9. So it's essentially the same thing that we just did, except we got to remember we have to write this thing out the correct way. So help me multiply this thing. First we have x times x. What does that give us? Okay, keep going. What do we get next? We need to distribute this one to the next number. Yeah, so 9x. Now we can move to 9, so 9 times this one. Yeah. And then we get 81. The order that you multiply them does not matter. I want to make that clear. But I don't want to skip over anything so we don't forget them. Okay? So now what? Good. So we have 9x and 9x. So altogether we have x squared, then what? Perfect. Any questions? Nope, still making sense? All right, keep going. Next, factor the following trinomial. If it cannot be factored, indicate not factorable. Now, I'm pretty sure that all of the questions that I put on the review can be factored. I'm pretty sure I didn't put any that are not factorable. Now, the way you tell is by using the AC method. So remember, these are set up as ax squared plus bx plus c. So our a here is 1, and our c is 16. So AC, 1 times 16 is 16. Now we need numbers that will multiply together to get 16. Starting with 1 and 16, what else? Oh, and it needs to be negative, since this is negative 16. Okay? Negative 2 and 8. What else? Well, we don't need any more, do we? Because these will give us our middle term. If we combine negative 2 and positive 8, they give us positive 6. So we can use that in our box method. Our first term is x squared. Our last term is negative 16. Then these two are just these two numbers. So we have negative 2x and positive 8x. Okay? Now we just see what's common for our rows and columns. So this first row, x squared and 2x, what do they have in common? What can they both be divided by? X. This row, what do they have in common? They can both be divided by bigger than 2. Go bigger than 4. 8, yes. We always want to go for the biggest one, so let's go for 8. But you're right, 2 and 4 are both possible. All right? This column, what do they have in common? So x squared and 8x can both be divided by x. They both have x in common. And 2x and 16 can both be divided by what? Well, 2 can't be divided by 8. The biggest thing we can divide it by is 2. Because nothing larger than itself can be divided by that. Like, so 8 can be divided by 2, but 2 can't be divided by 8. Okay? So there's our factors. X minus 2 across the top there, and x plus 8 down the side. Okay. Next one. Or first, any questions on this one? All right, next one. Use the special factoring methods to factor the following binomial. If it cannot be factored, indicate not factorable. No, this one absolutely can be. Now, it's kind of hard to see, but what kind of thing is this? Anybody remember what it's called? I'll give us a hint. It's a difference of something. Difference of squares. Perfect. Yes. Dead giveaway is that it's two numbers, and there's a difference between them. So x squared is literally a square of x, and 289. Does anybody happen to know what the square root of 289 is? 17. Very good. Yeah. So we know that this thing's going to split up into two parts. One of them is going to have a minus in the middle. One of them is going to have a plus. And then we fill in the blanks with the square roots of these numbers. So the square root of x squared is x. So that goes there and here. And then the square root of 289 is 17. So that goes here and here. And there's our factored form. X minus 17 and x plus 17. Any questions? All right. Next, evaluate the following square root expression. Now, we have a negative under here. So is this going to be a real number or a non-real number? If we have a negative underneath a square root, will it be a real number or a non-real number? In other words, are we going to need to use I here? Yes. If we have a negative underneath our square root like this, first thing we should do is take that negative out as I. Okay. So now we can ignore that negative and just deal with the 196. Okay, so square root of 196, it actually does take an even root. Anybody know what it is? I'll allow you to use calculators on the test, so I'm not too concerned with you being able to do it by hand. 14, yeah. So what we get here is 14i. Excellent. Any questions? Okay. Next, simplify the following expression. So we have i's in here, and we need to combine these things. Simplify the following expression. Now remember, I doesn't work any different from x. We can treat it kind of like it's a variable. So when we are combining things like this, so adding, we can only combine like terms. So what like terms do we have? Perfect. Negative 11i and positive 6i. So we can combine those. So what do we get when we combine these two numbers? Negative 11i and positive 6i. Okay? So it gives us negative 5i. Now, we have other numbers here. We have 6, and we have 12i squared. So as it's written right now, we don't have any like terms, but we can get another like term out of this. And it has to do with I squared. What does I squared come out to be? Negative 1. Good. Remember that I is the square root of negative 1. So if we square I, that's squaring a square root, those cancel and leave us with the negative 1. So this 12, if it's being multiplied by negative 1, it's going to become what? It'll be negative itself. So what we really have here is negative 5i plus 6 minus 12. So now we have more like terms. We have 6 minus 12. What does that give us? Negative 6. So we get negative 6 minus 5i. Any questions? All right. Next one says simplify the following expression. It's on the back. Okay. So it wants us to multiply here. It's just like when we were multiplying those binomials. In fact, this basically is a binomial. Now, something interesting to note is that these aren't just binomials, they are conjugate binomials. They're the same numbers, just this one has a negative and this one has a positive. Now, it doesn't mean we're going to treat it any differently, it just means that we know that the answer should be real. It shouldn't have I left in it anymore. But we're still going to treat it like any other multiplying binomials. We need to multiply by distributing. So 6 times 6 is what? Okay. What's next? Good. 6 times 3i is 18i. Next. Yes, good. Good catch. And last. Not 18. It is minus, but not 18. 9i squared. Yeah, there we go. Okay. Very similar to the last one. We can combine positive 18i and negative 18i, but what does that mean happens to them? Since one's positive and one's negative, what's 18i minus 18i? 0. Cancels. Gone. Okay? I squared. Remember, what is I squared? So if we multiply negative 9 times negative 1, this becomes what? Just regular old positive 9. Good. So now, really what we have is 36 plus 9, which gives us 45. Good. There's our answer. Again, when we multiply conjugate binomials, or in this case complex conjugates, we should always get a real number out. All right, one last one. Simplify the following expression: I to the negative 193. Okay, now we know that I follows a pattern in its powers. I negative 1, negative I1. I negative 1, negative I1. I negative 1, negative I1. It'll always be one of those four things. So we could count 193 places. That's not going to be very easy though. So does anybody remember what we can do instead with this power? I'll give you a hint. There's 4 steps in the pattern. Nobody remembers? All right. So if we are faced with something like this where we want to find out what this lands on, what value, what we do is we take 193 and divide it by 4. So 193 divided by 4 gives us 48.25. Now, if we refer back to a chart that I made for us one time, we said that I to the first is just I to the second is -1, I to the third is -I to the fourth is 1. And then I also said that these point to certain decimals. Because when we divide a number by 4, it can only come out to one of 4 decimals, either 0.25, 0.50, 0.75, or 0.00. So when we divide this, we get 0.25. That means we land on the first step of our pattern. So I to the add 2 places. So I to the -193 power, divide by that, we get 0.25. This lands on I. Now there's a problem here, and that's with the negative. When we have a negative power, do the same thing, add 2 places to it. So add 2 places to it, 75. This actually lands on -I. Okay? On the test, I'm going to try not to give y'all a negative exponent. I'm going to keep it positive so that you can just divide by 4 and then look it up. You don't have to worry about doing anything kooky with it. Okay? Any questions? All right, this is what you can expect out of that review. And I want y'all to do that review and get it turned in to me by Wednesday at midnight. Now remember, Wednesday is our exam. And this is going to be almost exactly like the exam, okay? So I'll see y'all on Wednesday. Make sure to get this turned in. I hope you have a good day.